Howdy! It's just your neighborhood physics teacher, and I'm here to talk about different graphs. We've been doing a lot of it in class, but I just wanted to get down to the basics and make sure we're reviewing and remember exactly what each part of the graph means. We'll talk about position versus time graph, talk about velocity versus time graph, and we'll even talk a little bit about acceleration versus time graph, but there's not very much to talk about that. But we'll talk about each part. So the first one we're talking about is our basic position versus time graph. Now, the first, we'll change colors. So the first one, it's our basic. It's just maybe, there we go. Straight horizontal line. Now, what does a straight horizontal line mean? So let's think about this. So if we had numbers here, so we had, that's our 0, we had 1, 2, 3, 4, 5, 6. So that's saying we are on position 4 for 1, 2, 3, 4, 5, 6, 7, 8. We're on position 4 for 8 seconds. So you have to think about that. Are we moving? No, we're not. Our position is staying constant. Our position is staying constant. Now, when our position's constant, that means our slope is 0. And since our slope is 0, means our velocity is 0. Because we're not moving, right? Our acceleration is 0. And all that rounds up to us being stationary. AKA not moving. So our blue line is saying we are not moving, not budging one bit. Now, for the next one, we're going to do a diagonal up. So diagonal up is showing that, our position is increasing, going from 1 to 2 to 3 to 4. And as our position's increasing, our time's increasing. So, therefore, for our green, our position is changing. We have to think how it's changing. So, our position is changing. It's a straight diagonal line, so our slope is constant. So if our slope's constant, that means our velocity is constant. If our velocity is constant, that means the velocity is not changing, so therefore our acceleration is 0. Now, we're going up the graph, so we're moving in a positive direction. Our numbers are getting bigger. We're going from 1, 2, 3, 4, 5, 6. Our numbers are getting bigger. So that's how we know we're going in the positive direction. So we have a couple, but for this one, we have another potential one we have when our line is going diagonal down. So diagonal down, our position is still changing. Our slope is still constant. So therefore our velocity is still constant. And if our velocity is constant, what's our acceleration? Yep, our acceleration is 0. But the big difference, you notice we have the same thing, position changing from the green, position changing for the orange, slope constant, slope constant, velocity constant, acceleration 0, but we're moving in the negative direction. And we know this because our numbers are getting smaller. And look, we're going from 6 to 5 to 4 to 3 to 2 to 1. Our numbers are getting smaller. So, now, how we keep throwing in slope and stuff like that, but what is our slope equation? So we know slope is rise over run. In this case, rise over run would be your change in y over change in x. What's connected to our y-axis? It's our position. So our y-axis is our position. Our x-axis, should use this a different color so you don't get lost, but our x-axis is our time. So you get delta t. And our slope in this case is velocity. And we can look at that by looking also at our units. So the unit that goes with position is meters. The unit that goes with time is seconds. So you get meters per second. So that's the unit that goes with velocity also. Ding, ding, ding. Here we go. This is all the straight lines that go with our position versus time graph. We do have some curvy ones too, don't we? So let's go back. We're going to redraw our position versus time graph, just because that other one was getting kind of crazy. My X was not being nice. So our position versus time graph. But in this case, we're going to deal with some curving. So our first curving one is going to look like that. Now, anytime you see a curve in a position versus time graph, what's the first thing you have to think about? Yes, accelerating. It is accelerating. It's accelerating, okay? So if it's accelerating, that means our velocity is changing. So how is our velocity changing? Well, if you look at it, at the very beginning, we have a horizontal, so it goes horizontal, to vertical. Another way you can look at it, it's going from shallow to steep. So that means it is speeding up. Now, since your velocity is changing, our acceleration will always be constant. It is accelerating, but it's accelerating at a constant rate. Is constant. It will always be constant for what we're dealing with. So your acceleration is constant, and then we have to deal with direction. So it's going up the graph, so we have a positive direction. So our next graph will be one that goes like, come on, here we go, like that. It's kind of like its opposite. So it's a curve, so we know we're accelerating. So if we're accelerating, that means our velocity is changing. But how is it changing? So let's look at our cues. It's going from vertical to horizontal. Or another way to look at it, it's going from steep to shallow. So that means it is slowing down. Means it's slowing down. Our acceleration is still constant because it will always be constant. But what direction are we going? So again, we're going up the graph, so we're still moving in the positive direction. So now let's deal with a graph that kind of looks like that. So again, it's a curve, so we're accelerating. So we're accelerating, our velocity is constant, our velocity is changing, velocity is changing. How is it changing? Again, we're going from vertical to horizontal. So if we're going vertical to horizontal, we're going from steep to shallow. Again, that's just another way of looking at it. So that's telling us we are slowing down. Our acceleration is always constant. That does not change for a curve. It'll either be 0 or constant. That's your two choices for acceleration. But our direction's different. We're going from top to bottom. Our numbers are getting smaller, so we're moving in the negative direction. So we're moving in the negative direction. We have one more curve to deal with. So our last one goes like this. So we're still accelerating because there's a curve. It's always accelerating. If there's a curve, if it's accelerating, our velocity is always changing. Just how it's changing, that's what we have to look at. So we're going from horizontal to vertical. Or another way of looking at it is we're going from shallow to steep. And that means we are speeding up. Acceleration is always constant. And we're going from bottom to top. We're going from top to bottom. So our direction is going to be negative. So there's our 4 different curves that we have to deal with. Dun, dun, dun. So we are done with our position versus time. So now let's move to velocity versus time. These graphs will look just a little bit different. So velocity versus time. You will not see any curves in this situation. You will only see straight lines. So, first one you'll see is the first one you saw in position, just or diagonal line going up. So, if you see a diagonal line going up, you know that your velocity is changing. So you know your velocity is changing. Velocity is changing, that means our slope is constant. If our slope is constant, that means acceleration is constant. And our velocity is changing in the positive, our numbers are getting bigger, so that means we are speeding up. So since we are speeding up, and we have to decide which direction we're speeding up in. So are we speeding up in the positive or speeding up in the negative direction? So again, our numbers are getting bigger, because if we had numbers here, let's go back to, we had numbers here, so that's the 0, that's 1, 2, 3, 4, 5, 6. So we're speeding up because our numbers are getting bigger, but we are in the positive quadrant because all the numbers down here are negative, -1, -2, -3, -4, -5. So we're speeding up in the positive direction. So we're speeding up in the positive direction. So if we kind of remember that, if we draw a diagonal line going down, let's think about what's going on here. So we have velocity is still changing. And our numbers are, and so therefore our slope is constant. If our slope is constant, it means our acceleration is constant. But we have to look at our numbers to decide if we're speeding up or slowing down. So our numbers are getting bigger, even though it's -1, -2, -3, -4, -5. Remember, the negative just means direction in physics. So our numbers are still getting bigger. So we'll be speeding up. We'll just be speeding up in the negative direction because our numbers are negative. We'll be speeding up in the negative direction. Now, we basically have two different horizontal lines. We have horizontal in the positive and horizontal in the negative, but they kind of mean the same thing. So it means our velocity is constant. Our velocity is constant. So if our velocity is constant, that means our slope is 0. If our slope 0, that means our acceleration is 0. So if our slope 0, our acceleration 0, we just have to decide which direction we're in the positive, where the numbers are positive, so we're in the positive direction. So do your exact same thing in the negative. So we have our velocity is constant, means it's not changing. Velocity is constant, so our slope is 0. So therefore our acceleration is 0. But we're just in the negative direction because we're where the negative numbers are. Negative direction. Two more lines to look at. We'll be done. So our second to last line would be the blue line. So our velocity is changing because numbers are changing, so our velocity is changing. So therefore our slope is constant. Our slope is constant means our acceleration is constant. You just decide how is it speeding. You have to decide if it's speeding up or slowing down. We're going from bigger numbers to smaller numbers, so that means we're slowing down. We're just slowing down in the positive direction because our numbers are positive. Our numbers are getting smaller, they're just getting smaller in the negative direction. One more. Let's do one more. We have that line right there. So again, our velocity is changing. If our velocity is changing, that means our slope is constant. If our slope is constant, our acceleration is constant. You just decide, is it constantly speeding up or slowing down? Let's look at our numbers. Our numbers are getting smaller. Even though they're negative, our numbers are still getting smaller. So we are slowing down. And we're just in the negative direction because our numbers are negative. So we're slowing down in the negative direction. So there we go. There's two more other concepts I want to make sure we understand with the velocity versus time graph. So I'm going to draw this again. So velocity versus time. Let's get a different color. So so we have a graph. So if we're trying to find displacement, we have to do what's called area under the curve. And I put curve in quotations because is there a curve? No. So basically you have to do area of a triangle. So you do area of a triangle, which is 1/2 base times height, and you do area of a rectangle, which area of a rectangle is just base times height. If it's in the negative side, you subtract. It's in the positive side, you add. That's if you're trying to find displacement. Trying to find distance, you add them all up. Next thing I want to make sure you understand dealing with your velocity versus time is think about what happens right here. What's happening right there? So this is the positive, and that's the negative. So anytime you cross the zero line, you're changing direction. Changing direction. Another way to think about it is you're turning around. Changing direction, you're turning around. So that's basically, I just want to make sure you understand that you're turning around right there. So if we're looking at how things are interacting, before you're turning around, you're slowing down because our numbers are getting smaller. So you're slowing down. Then on the bottom, your numbers are getting bigger, so you're speeding up. Okay. There's not much to the acceleration versus time graph. You can only really have three choices. You have that, which means your acceleration is constant. Your acceleration is constant. So your slope is 0. And you're in the positive direction because you're on the positive side. You have another one. Your acceleration is constant. Your slope is 0. We're just in the negative direction. And of course you have just the basic on the 0, and it just means your acceleration is 0. And you have that for all. Anytime they're on the actual 0 line means whatever it is 0. So hopefully that kind of helps break down graphing for you. And maybe you can see how different things interact. If you have any other questions, please let me know. Have a wonderful day.